Now from this quadratic formula that we know, there is something that is very important that we need to take note of. So we have b squared minus 4ac over 2a. So we have what we call the discriminant. So the discriminant, which we call d, is the term inside the square root, so which is b squared minus 4ac. So why is this discriminant so important? It helps us to determine the nature of the roots that we have for that particular quadratic equation. So there are three types of roots. So we can have real, different, or distinct roots, and then we can have real equal roots, and then we can also have complex roots. So we need to know the scenario for each. So the discriminant helps us to determine that. So the first case, if the discriminant value is more than 0, what we have are two real distinct roots. Number 2, if our discriminant is exactly 0, then the roots are equal, so you have two equal real roots. And if we have the discriminant less than 0, in other words, if the discriminant is negative, then you have two complex roots. Okay, so let's have an example. So if, for example, we have 2 plus 9x minus, say, x squared is equal to 0. So remember the quadratic formula, it's ax squared plus bx plus c is equal to 0. So we need to bear this in mind. So we need to check the coefficient of x squared, that is our a, the coefficient of x, that is our b, and the constant term, that's our c. So in this case, our a is not 2, but the coefficient of x squared here, which is -1. Our b is 9. Our c is 2. So d is b squared minus 4ac. So in this case, we're going to have b squared, which is 9 squared, minus 4 on a, which is -1, times c, which is 2. So we have 9 squared, which is 81. Negative times negative, that's positive. 4 times 1 is 4. Then 4 times 2, we have 8. So 81 plus 8, that's 89. 89 is a positive number. So we have two distinct real roots. Okay, so now what if we have 3x squared minus x minus 5 is equal to 0. So our a in this case is 3, our b is -1, and our c is -5. So our discriminant is b squared minus 4ac. So our b is -1, so we're going to square it, minus 4 times a, which is 3, c is -5. Negative 1 squared, that's positive 1. Negative, negative, it's plus. So we have 4 times 3 times 5. So we can have a 15 when we multiply 3 by 5. And then 15 by 4, that's 60. So we'll have 61, and 61 is also more than 0. So in this case, we also have 2 distinct real roots. Okay. So if we look at another example, 3, where we have x squared minus 2x equal to negative 1. So we'll rearrange it in the standard form. So we have x squared minus 2x, negative 1 will go this side. So we'll have plus 1 is equal to 0. So our a in this case is 1. Our b is negative 2. Our c is also 1. So d is going to be b squared minus 4ac. So our b is negative 2. We are squaring that. Minus 4 times a, which is 1, times c, which is also 1. So here we'll have negative 2 squared, which is positive 4, minus 4 times 1, that's just a 4. And we'll get a 0, which is just equal to 0. So if the discriminant is 0, then we have 2 equal real roots. Okay, and then we look at this example where we have x squared plus 3x plus 7 is equal to 0. It's already in the form that we want. We go straight and say a is 1, b is 3, and c is 7. So our discriminant will be b squared minus 4ac. So this will be equal to our b is 3. We are squaring this, minus 4 times a, which is 1, times c, which is 7. So this will be 9 minus 4 times 7, that's 28. Then we'll have 9 minus 28, which is negative 19. And negative 19 is less than 0. So in such a case, this quadratic equation will have 2 complex roots.